Welcome to the 8th part of TIS-100 Signal Edge Detector. Before I go into this, I'll briefly come back to my previous solutions, and I have this program which I reduced the cycles by actually having parallelization, which is the achievement that you get for doing it. Basically, I'm getting an input moving it right, moving it left. So each time in this node, I'll get an input, so I'm not waiting for the input at any time. And then I'm gonna increment both of them, and then one at a time from top to bottom, I'll give the input, like so. And that reduces the clock cycles. Then here, 30, this one, I did some parallelization as well. Well, not really parallelization, more like I don't do everything inside of the A box. I do it in A and B. And, you know, same thing. Here, I don't think I reduced it. I don't think I touched this. Or this, yeah. Okay, so signal edge detector. Read a value from in. Compare value to previous value. So, okay. Compare value to previous value. 0 compared to previous value 0, okay. Write 1 if changed by 10 or more. So there is no value, so it's not changed, so it's a 0. This has been changed by 10 or more. If not true, then write 0 instead. The first output is always 0. Yeah. So this was changed by 10. Okay, so the idea is I would receive input. I would switch. So I receive input, move up to accumulator. Or I guess I'll say I'll move it left. It'll move it right. Let's not worry about parallelization. Move up to the accumulator. Yeah, move up to the accumulator. Whatever. Yeah, because the best thing would be to always receive input. But we won't be able to do that, probably, because you have to have the previous value. Anyway, now you do swap. You say, how about you swap at the start, you move up, you sub the up with the accumulator so far. No, you sub the accumulator with anything that's up. Okay, so back will be our value, and it has to be changed by 10. So we have 0. Take 0, 0 now. Yeah, by 10. So 32 minus 0 changed by 10. 30 minus 32 did not change by 10. But there is no CMP instruction in this assembly program. So how would I check if it's changed by 10? 10 or more. I can, no, I think yeah, I subtract this by this, and then I subtract 10, and if it's 0 or more, then it is greater than 10. So 30 minus 32 would be 2 minus 10. It's negative, therefore it's 0. Blah, 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 blah. 13, so, ooh. Yeah, when we do subtraction, we'll have to find the positive value. So, so let me get my drawing thing out and see. So we have, I'll call it previous and next value. So call it next value, and I'll call it pre first. So this will be kind of pseudocode. So we have prev equals, let's say 12. Next is, let's say 2. So it is that, right? So what I'm going to be doing is I'm going to be 2 minus 12, and I'm going to find the positive value of that. And the way I would do that is I'd have to check if the value is negative. If the answer is negative, I guess you can say less than 0, then give me the answer. Then I guess negate the answer. Else I would just return the answer. Just the answer stays the same. I guess else you don't even need else. Right? So therefore, I guess I'll put in a comment. Therefore, 2 minus 12 is 10, because it's the positive. And the next step would be ans minus 10 is, if ans minus 10 is greater than or equal to 0, then return 1, else return 0. Basically, yeah, that makes sense, I think. And it works the same for, let's say, 12 minus 2. It would just be 10. We don't really care about that. We don't negate. So it'd be 10. And 10 minus 10 is less than or... I made a mistake, yep. Not less than or equal to, greater than or equal to. So there is a change. And it is, okay, so it would be valid for 100 minus 1. It would be 99. Then 99 minus 10 is obviously 89. It is greater than or equal to 0. That is a big... that is not a big change. It is not a change by 10. Yeah, that's my flaw. I'm looking at the inputs, and the inputs aren't that big. I'm thinking, does my incorrect implementation still work though? Read a value from in, compare value from the previous value, write one if changed by 10 or more. There will never be higher than a 10 higher than a 20 change, which makes my pseudocode right. Do I assume this? Because 24, never higher than a 20 change, which means my program works. Okay, well, let's try this. So I have 89 now. Then I want to do 100 minus 89, which is equal to, what is it, 11? And if that's greater than or equal to, and if 11 minus 10 is greater than or equal to, less than or equal to 0? No. No. I was looking at that part. I should be looking at that part. It's 100 minus da. Then I do 100 minus 99. That must be that must be 1. One must be, well, it technically must be this. Sorry, greater than or equal to 10. That's the condition we want to satisfy. But what we can do is we can do 1 minus 10, 10 minus 10, and say minus 9 is greater than or equal to 0. Which it's not. It's not. So then how would I write it in code? Is there a box I can align, eraser? There you go. So I don't want to be doing this, but I'm doing something very similar. I'll be doing if, so it's the answer is negated, blah blah blah. 10, which is this. We want to do what was it, prev? No, next minus prev. It's next minus prev in that case. Then I want to do next, what is it, 99, 1. No, it's the answer, 1. Next minus prev. I'm losing my mind. Yeah, next minus prev. It's this minus this. Next minus the answer, because it has been negated at this point, should equal to, it should just equal to this. Should it not? Let's see. 2 minus 12 is equal to 10. Then we do 2 minus 10. 2 minus 10 is equal to minus 8. Minus 8. Minus 8 minus 8 minus 8 minus 8 minus 10. Well, this is 10 or more change. So maybe I do have to say modulo this as well. So it'd be 8. Must be greater than or equal to 10, but we can just take 10 away. Minus 10, 10 minus 10, and we can say minus 2 is less than or equal to 0, which it's not. Which it's not. No, it 8 minus 10. Two minus 10 is minus 8. You get the absolute value of that, and you take away 10. What is happening? 3 minus 7 is equal to 4. How about we don't find the positive? So 3 minus 7 is equal to minus 4. Minus 4 minus 4. Sorry, not minus 4 minus 4. 3 minus 4 is equal to 7. We take away 10, Minus 10. 2, 10 minus 10. But the thing is, it can go back to the negative. So as long as the change. Minus 3. And then maybe we say that's false. But 3 minus 13 is equal to minus 16. I'm losing my mind. Minus 10. 3 minus 10 is equal to 13 minus 10 equal to 10 minus 10, and then say 3 0. Okay, and it should work the same here. Equals 10. 3. Oh, it does not. So do we have to make this positive? This always has to be positive? Minus 7, minus 10. I guess we can make this positive, so let's make it a plus. Ooh. Yeah, no, that would fail. Oh, we make that positive, and then we make the answer to that positive. That's what we do. We do 2 positives. So we have to do 2 checks. And then will that work for 100 minus 1 is equal to 99? Then you say 100 minus 99 is equal to 1. So it's 100, 10. And then we say, sorry, 3 minus 10 was it? Oh. I was doing this wrong. Yikes. 13 minus 10 is equal to 3. So if I could just check these two. If I could just check these two. Somehow, well, I can loop subtract to make sure that one of these is bigger. And then I can do this thing. It's just algebraic thing where it's it's minus 3 minus 10 to minus 13. We plus it. We take 10. 10 minus 10. 3 is less than or equal to 0. But that will require me to need to take away that using like loops, which isn't nice, and I don't want to do that. So is there another way of writing this? 13 minus 3 is equal to 10. I want to use the same kind of algorithm, but I get 3 this time. And 3 minus 10 is greater than or equal to 10 minus 10. And then what is this, minus 7? But then we want to plusify it. Okay. Okay, so that worked, right? How about the obvious answer? 100 minus 1 is 99. 100 minus 99 is equal to, so happens to be 1, this thing. Doesn't have to be. And then we say 1 minus 10 is less than or equal to 10 minus 10. And what was I was saying 9? Well, clearly this is wrong. Clearly there wasn't a 99 change. Wait, does the answer really want us to loop and just do take away 10, 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 take away 10 each time? Take away 10. Basically, so if it's 100, it's going to take away 10 times. And then if it's like 1, it's going to take away 10 one time. And it's going to say wait a minute. Oh my god. 100 minus 1 equals 99. It's definitely a 10 difference. For God's sake, it's a it's a 10 difference. That is right. I don't know what I was thinking. Okay, how about 10 minus 11, or 11 minus 10. 11 minus 10 is equal to 1. 11 minus 1 is equal to 10. Minus 10 is equal to... Okay, this looks wrong. My algebra just doesn't actually work. So maybe it has to be just greater. I don't see it working. Because if I get this, it's equal to 2, and then I say 11 minus 2 is equal to... Am I just rewriting algebra? It will always be that. I am rewriting algebra. I'm doing this. So why would I even do that? Why? There is no reason why I would do that. Yeah, okay, so the obvious way, let me just remove all of this. It's a super inefficient way and I hate it. but it would be to, yeah, it would be to take away x number of times, let's say times x times y. So I'll call this prev, I'll call this next. So we do that, and then we have like a counter. So this has a counter of the minuses. Oops. This has a counter of the minuses. So there's this, and then we say, duh, that's just normal assembly language. I just want to compare the two. So this is 5 and this is 4. Then if I do 5 minus 4 and it's greater than or equal to 0, it's greater than 0, then it's good. So if I have the number 4, I would take it away once. Now it's a negative number. So this is prev. And if I have the number next and I say this is 25, then I take away once, twice, 3 times. Now it's minus 5. There is a, so this needed to be taken away 3 times. What if it's 24? What if it's 14? Minus 10. Minus 10. That's twice. What if it's like just 10? I guess if it's just 10, it has to be less than 0, which means one more time. So that's twice. Oh, no. If it's just 10, take away once, now it's 0. There isn't a 10 difference. What if it's 13? Just less. 10. No, you would have subtracted 10 twice already. That would give minus 3. And obviously, the amount of 10s, we didn't have to subtract, we had to subtract 13, we had to subtract 4. 4 minus 13 isn't greater than 10. So what? What do I do? There must be something related to subtracting these two numbers. There isn't. There can't be anything else. Well, maybe there is something else, but we're comparing the two numbers, therefore we have to do something with both of the numbers together. Wait a minute, is it just no, please don't tell me it is. You just take away the two numbers and compare if it's greater than or equal to 10? That's all you had to do? Oh yeah, but we can compare greater than or equal to 10. But then we can take away by 10. Jesus Christ, that's what you have to do. equal to 0. Okay. That's all you had to do? Wow. I overcomplicated the heck out of it. But I started with the correct idea. Four minus 13, though, will be minus 9. But what I would do is I want to make it a plus. Then I want to take away 10. Because it's a 10 difference in the opposite direction. And we don't care. Minus 1 is not equal to 0, so it fails. So that fails. 4 minus 23 will give you minus 19. I'll make it a plus. Blah, blah, blah. 9 greater than equal to 0. Okay. Okay. That's the approach. That's the algorithm. So what else? So how do we do it in assembly with 2 registers? I mean, we have more, but we can theoretically do it in here. Or I can move the computation to the right. I can move the computation, so how about I subtract here? I'll say move up right, move up down. I won't subtract here. And I'll combine the two together or something. I'll say move up to the accumulator. I'll say oh, I need the two numbers. I can't do that just yet. Move up to the accumulator. And then I say so it'd be 0 minus 32. That's not what we want. The first number will be a 0. Which means this does not look right. Because what I'm going to be doing is, well, yeah, I would get all of these numbers. So I guess I'll have a condition where it says if ACK is 0. Yeah, something like JZ. If ACK is 0 equal to 0. First, what does it compare? The previous value. Not true. The first output is always 1. Output always 1. That's a terrible label. I'll say out 1 always. First out. First out will be move. But we need to receive input first, so I'll say move up, down. No, move up to the accumulator. No, I can't do that. I need to like stall the program. So want to receive input, which is our first answer. Sure, I'll say an accumulator, then I'll say swap. And then I'll say, so now this is the first output, so we move 0 down. And then I say add 1 to the accumulator, swap back. And then here, therefore, if it's not this, then I'll just move the I'll swap back, move the accumulator, swap back, move the accumulator down, because that's our answer. And then jump to the start of the loop. There you go. Okay. Yeah, that's fair enough. Then I do 32 minus 0. So I do. Let's actually do that example right here. I'll be doing, where's my, here we go, 32 minus 0, which equals to 32. Yeah, okay, so it's not a negative condition. So 32 minus 0. Now the accumulator has lost the number. It has lost the number. Which number has it lost? Well, it didn't have any of these. Well, move accumulator down. So 32. 32 has been lost. But we don't care about it. Yeah, we don't. Okay, so this is now our new accumulator. And then we say sub the accumulator by 10. No, we have to first check if it's j less than 0. Then we have to do the negate. Then we say negate the thing. Jump to the rest of the program. I guess we could do the opposite condition. Yeah, it'll make more sense to do the opposite condition, to say jump less than 0. Nah, we'd have to do two conditions. Yeah, I'll just say jump less than 0, jump to I'll actually call it negate just so it doesn't get confused with the operand. I'll say jump to I don't know. I'll say just no. It's not in. What label should I call it? Sub 10. Sub 10. I'll call it 10 or something. I don't know. And then I guess I'll just add spaces because I have space. And then I'll say move up accumulators. So 32 minus 0. If it's a negative number, I want to make it positive. Then I go here. Then I want to, so it's 2. I want to sub the accumulator by 10. So I want to do 32 minus 10. And then we have to say jump less than 0. No, it's greater than or equal to 0. Greater than 0, jump equal to 0. End. And then I'll say end, move 1 down. And then if it doesn't jump to the end, then we want to jump to the start of the program. Or not, we actually move 0 down, jump to the start of the program, and I'll just call it L for loop. So it's moving it down, so move up, down, and then I'll move up, right. And then that means I receive from the left. So 30, no, it's 0 minus 32. Zero. Yeah, it's 0 minus 32. I want to do the other way around, but that doesn't matter. That doesn't matter. In my logic, it doesn't matter. It'll just jump to the negative. Now it's positive. It'll subtract by 10. And then it says it's greater than 0. Therefore, I'll move 1 down. Okay, so does it ever actually give 1? It does. Wait, there's a deadlock. That's fascinating. Wait, where was it? Where's the deadlock? Somehow here. Okay, never. Wait. Value. Okay. I take away 32. Then, wait, hold up. Yeah, take away 32. Then I negate. Then I take away 10. So 32 minus 0 is obviously a 10 or a greater difference. So I'll move 1 down. So now I receive input. Now, so this is the first answer, so we have to give 0 first. And it's doing that thing. It's doing 30 minus 32, I hope. It's not. So 1, 1. The answer of 1, 1. I'll swap back. I'll say move accumulator down. Then I'll say swap. So many swaps. Jump L. So I'm just focusing on this node for a second. So 0 we want to give. Okay, hold up. 1. We want to move 0 down first, then 1. So 0 has been down. Now we swapped it to our actual value. We move that down. Then we want to swap back to the back, which is like the test we have to do. Yeah. So 1 is the first answer, but we're going to do 0, 1. 0 is the next answer. And then 0 is the next answer. And then 0 is the next answer. 0 is the next answer. Okay, it fails. Okay, so this kind of makes sense. How about this part? It's very slow, but it's whatever. Blah, blah, blah. Okay. Then it does 30 minus 32. Ah. It's doing 30 minus 27. Yeah, we have to swap. And we need to make space now. Ooh, so it's more tricky than that. So I might utilize this part. Might utilize the left node to do my move accumulator down. Instead of sub up, I'll say sub, say move up left, move up left, move up accumulator. I'll move it left, up left as well. Then I'll say move right to the accumulator, sub the accumulator, sub from the right, which has the previous value, and then accumulator, sub from right. No. We'll do a swap. That's the previous value. That's the previous value, and then we say move. No, we can't do that. How about we do this stupid thing of saying the first value is actually the second value? So we're gonna say move. Yeah, we're gonna say move right to the accumulator. Then we're gonna say save the accumulator. 2 back, then you say subtract the right with the accumulator so far. Oh, it actually doesn't matter which way we do it because I have that condition. Nice. Sub from the right with the accumulator. And then we say move the accumulator right and then swap. But then that means we only need to do the previous value. Interesting. That means we only have to give it once. Sub by 0, because that's the first answer. Which means I might not have to do all of this. By sub by. Sub by 0, but it's not 0 because it's not going to stay 0 for long. It's actually what's in back. So we're going to say sub by down. Yeah? Yeah. I'm going to utilize this one. So it's going to say, so what I'm going to receive an input from in, like 0. I'm going to save it to the register. This will give me my back. The back. Save, swap back. Swap. Move act down. Then you say, yeah, and then you say move up, because I'll swap back. Sub down. This looks awful. So it's, but now it's going to be waiting for input, right? It's not waiting for input. It has to wait for input. Move up left, and then I say move left to the accumulator. So it saves it, swaps it, down, swaps it, subtracts it, move accumulator right, swaps it back. It's gonna give me 2 zeros, yeah, of course it will. Clearly it's less than 0, or am I? Greater than or equal to 0 or 0. Okay, we have to remove this part. I'll just put in here, but we won't need it. I'll just put the whole thing in here. Move left accumulator. Just move left down. That's all we need to do. So get 0, we do the swaps. Subtract by 10. Down. Now it's 32. Now we save 32. This has, just gonna do 32 minus 0. No, we can't save it. No, we have to save it. Okay, the zeros don't make sense, so I'm gonna wait until it gives me a different answer. So 32. I don't think we swap it here. You want to save the 32 for later? Or how about we move accumulator down? Save for later. Instead of using the save. Down, down. To the accumulator. I guess, and then we'll swap. Swap here. How about we swap here? Okay, makes no sense for the 0, but okay, here. A deadlock. Wait, it can't give input back? Or it just won't? Oh, it's a deadlock because... wait, how do I receive the input? Up? I thought it was down, right? Move up. How do I do it? Oh, shit. Okay, 32. It's gonna give me 32. I'm gonna subtract. I'm gonna subtract, huh? It's gonna be zeros forever. No, that felt very close. -30 minus 32 is 2. -27 minus 30. I've lost it. Good, we need both of the numbers here. We need at least one of these numbers here. We need to remain, 30 needs to remain. Should maybe a swap save be used? Will that make more sense? A swap save. There you go. A swap save. This is probably awful. It is. It just keeps getting worse. But it works, and we don't, oh, and the reason why there are so many instructions is because, I mean, this isn't even used. Wait, did I reduce cycles? I don't think it would have, but it did. Maybe, could have, would have, should have. I guess I can literally do the same thing here. Yeah, up left. I guess I'll say up accumulator, move up left, move up, sorry, move tuner left, Move accumulator right. No. It's gonna be move up. Move up. Left. Okay, make sure it still works. Okay. Move up left, move up right. You do the same thing. You do the same thing. And move back up. Will that somehow make it more efficient? Yeah, we have to left instead of right, it goes left, up, yeah. Will that parallel? No, it won't. It doesn't know the previous value. It's gonna be all wrong. How slow is it in like just run mode? Oof. I mean, I can make this more efficient. Let me try. Like, because I'm doing lots of save swaps. No, actually doing only 2. Huh, that's surprising. I felt like I did a million. Probably because this one that I deleted, that I used here at some point. Sub it by 0. Yeah, I feel like you don't want to be doing this. Move up left accumulator. You don't want to be doing this here. You want to be doing it here. Yeah, something like that. You can parallelize this better. Jump L. Oof. Jump L. Yeah. Yeah, you don't want to do that check. And move it down. And then jump L. Jump L is just here. But then this doesn't really help. You'd want to do GLZ. GLZ first. Yeah, GLZ. And then if so, you want to move the accumulator right. Move left accumulator. Sub 10. Sub 10. GZ end. JEZ end. Move 0 down. Yeah. And move 1 down. No, but it's not doing the GLZ check. So we don't need end. No, but it's subtracting by 10. It's gonna do the end check. Jump L. You happy? So I subtract 10, jump L. Don't care about the 0 check. And then the negative check. Negate. Negate check will just jump to 10. We'll negate and move right. Move accumulator right. end. Is at the end label useful? No. Yay, deadlock. Why? Oh, it's because of this, yeah. This isn't being used anymore. So I don't think I actually made anything better. I mean, I could have. It's still just still waiting forever. And the values aren't even right. They're gonna be one off my bet. 1. They're all zeros? Blah 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 blah. What is this? Champel. Yeah. 400 cycles, that's a lot better. I'm actually more happy with that. That's a lot better actually. But yeah, the negation can actually, instead of putting it here, I can actually utilize this more. So I can say, so actually, I like to keep my programs, I like to have multiple programs just to see different ways of doing it. So I'll actually move it down. And I'll say, I'll just do this thing basically. Just so the pipeline, I think the pipeline will be better. Move up to the accumulator. Right. And right. Move up, down. So what will execute first? Probably this wants to be here first. Down. Let's see. Ooh, I didn't want to do that one to the step. Right one. Sorry, not right, left. Oof, that felt so slow. Why was it so slow? Oh, it wants to receive input, but it doesn't. Because we're waiting on this. Because it won't go in order. It might. So I can actually do any down. There is a chance this will work. Yeah. Way worse, it seems. Well, more instructions for same amount of cycles. Yeah. And any just can receive any Pardon me. Yeah, it's not better. Yeah. Wait, instead of bringing it back up, why don't I just bring it left directly to the right? Because that takes 1, 2, boom. I could right, I can receive from the left, like so. Yeah, look at that, way nicer. We can remove this. We can go to the right, and then not any down. I'll just do up down. 360 cycles, 6 nodes, 27 instructions. What else could I do? This looks very like, this feels like a lot of stuff, but this is kind of important. The negation though. Is the negation ever executed? So is the LZ flag? Yeah, it does jump. So why does it actually become negative? Does it actually become negative just once in the program? Or every single time? No. Wait a minute. Hold up. The negation doesn't matter. The negation does not matter. Yeah. Jump L doesn't need to exist anymore. And then this is just a little trick where I can basically send 2 pieces of information. So I can send the accumulator twice because I'm doing swaps and I'm doing like arithmetic operations. So it's like, in a sense, it's like an extra register for me. It's like a little cheaty way of doing it. I haven't thought of a better way of trying to emulate that. I think you'll have to use more of these things, but yeah. I think I can actually optimize. I could have optimized this if I moved it right. Move it down and here. Maybe I sub 10 in one of the... So I'm looking here and it's just a little too involved. 2 conditions. These conditions could be checked elsewhere. So instead of JZ, wait a minute. This does 2 checks. Jump greater than 0, equal to 0. So if I want to do the opposite, I would do jump less than 0, move 1 down, 0 down. That saves an instruction. I mean, it's fairly good now. I'm pretty happy with that now. It went from 600 to 238. So that's pretty good. And the amount of instructions reduced. So the 400 is improved, and now this is even more improved. Yeah, I mean that's fairly good now. Quite quick. You can see the idle. Yeah, this is being idle for a while. It would be super nice if somehow I could bring it here, but then I don't have the previous value. Okay, let me think. Okay. What? How do I make it better? I don't know. Move it up. Because this moves it right directly, right? Boom. So instead of sub up. No, I have to do sub up. Instead of swapping and swap save. Swap save. Swap swap. No, of course not. Because the whole point of this is back. What if it's save swap? So bum bum save swap. No. Save swap. Swap. No, 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 no. That'd be wrong. What about save? Save. Swap. Swap. Okay, never mind. I think it's fair. This is good enough. Just one. How do I reduce just one more instruction? There has this thing. I hate it, but it works. Yeah, and I have to save it to a register so that I can send it down twice. No, it's something to do with this. These two nodes can somehow be optimized. Or maybe not. Or maybe not. Let's do negations. Is there a... Can I... Yeah, I think the negations can somehow be optimized. Just because... No, I can't. It simply can't. Ooh. This is an optimization. Move left accumulator. Why would I do that instead of just subbing 10? Sorry, sub 10 from the left. No, I have to do that. Oh, I thought I spotted one. Is there like a control F, like a search feature? Let me look at the manual. Arrow keys, view quick reference, begin running the current program, pause. Oh, never mind. Sub 10 from the left. But you only sub from the accumulator. So I have to do this. What if I sub 10 here? Ooh. What if I sub 10 before negating? Ooh. That means I can just... No, that won't make a difference. It could be, yeah, it could be more wrong, to be honest. Yeah, because the negation check. Negation check. Okay, no. Oh yeah, because I forgot the sub. Yeah. Yeah. It's pretty optimized, I must say. It doesn't wait too long.
Why do you...
Apologies. I have a brother who's entering my room constantly, so I'm doing my best trying to move my mic. Hopefully I'm doing a good job. Well, obviously this works while I'm stepping through it. Any other way? I know there must be many ways. I definitely did not create a perfect solution. It may, at best case scenario, it's good enough, you know. But I know I can make it better. No, this thing's pretty good. I mean, it's only a few instructions, and it does what I wanted to do. This is needed for this. Move left. I guess I can get rid of the label. Does that change anything? Does having a label change anything? What if I have... No, it doesn't. It does this thing. Could I optimize it? No, it's pretty good. I thought if I sent it down here and did the same thing, it wouldn't be so bad. But it is. Okay. Where's it? So 10, any down. No, it's just more instructions, same cycles. Same cycles. No, whatever. That's fairly good. It's fairly good. Just removing one instruction saves so much time. Hold up. This and this. No, that's because I'm swapping. 32. Ooh, wait a minute. Wait a minute. I get 32. I sub it. I swap it. I save it. I have 32. No. That's really good, and this is good, and that's good enough. Okay, I think that's good enough. Yeah, that's good enough. Okay, thanks for watching my playthrough of the 8th part.